Okay, in this video I'm going to show you a couple examples on how to solve quadratic equations with the quadratic formula. I'll do 3 examples that are pretty similar to each other, but that show sort of fundamentally different things that can happen when you use the quadratic formula. So just as a reminder, what is the quadratic formula? Well, we can use it, and this is a really important part of the formula, if we have an equation that says ax squared plus bx plus c equals 0. So if we have that, then our x value is equal to, so it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So a couple of important things to point out when you write this down. First of all, remember that we have to have it nicely arranged like this, and it's got to be equal to 0. You're going to have to memorize this formula. I'll make you memorize it for your quiz, but probably not for your test. So you have to memorize it. Then when you write it, make sure that the square root sign comes all the way across over the whole thing, and make sure that the fraction line comes all the way across under the whole numerator. Because if you write it differently, it actually means something different. Okay, so here we go. Casey throws a ball in the air. If h represents the ball's height in meters, and d represents the horizontal distance it travels in meters, then its path can be represented by the equation h equals negative 0.04 d squared plus 0.8 d. In this program I'm using, I don't know how to make that be, the little 2 be an exponent. So this here is like how you put it in your calculator, d squared, d exponent 2. Okay, so the question is, at what horizontal distance will the ball be 3 meters high? So what I'm going to do first of all is I'm going to take my 3 meters here, and I'm going to substitute that in for the height, because that's what it is, it's the height. So I'll have 3 equals negative 0.04 d squared plus 0.8 d. So now I have a quadratic equation that I can solve. I'm just down to one variable. I only have d's and no h's left, because I replaced my h with 3. So I could solve this using the quadratic formula. The only thing I've got to watch is right before I do it, I'm going to isolate it, I'm going to rearrange it so that I've got it equal to 0. So on both sides, the way I'm going to do that is I'm going to subtract 3 from both sides here. Minus 3, minus 3. So I'll have 0 equals negative 0.04 d squared plus 0.8 d minus 3. Okay, so now I'll just identify my a and b and c values. So I'll have a equals, and a is my coefficient on d squared. So a is negative 0.04. B, that's the coefficient on d, so 0.8. And c is negative 3. Okay. So now I'm ready to substitute into the formula. So I'll just tuck these equations. Oh my original equation is going with that. Tuck them over there. Okay, so I'm ready to substitute into the formula. So I'll have x, normally I would put x equals, but in this case my x is d. So it's actually really important to write whether it's x equals this thing or d equals or what, just so we remember what we're talking about. So my formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So my negative b, that's going to be negative because it's negative 0.8. Plus or minus, and then we have the square root of, so b squared, 0.8 squared, minus 4, and then a is 0.04, and negative 0.04, and c is negative 3. So there's b squared minus 4ac. I'll make sure my square root sign covers the whole thing. And all of that over 2a, which is 2 times negative 0.04. So there we go. It's really important to show just that line right there. I've just done the substitution. Okay, and so I need to see that in your solutions, just right there. So you're just replacing your A's and B's and C's. Okay. So then the next line, I would suggest the way you do this to minimize the chance of making little mistakes is that you take everything in the square root sign here, and you just plug that in your calculator all in one go. So 0.8 squared minus 4 times negative 0.04 times negative 3. So when you do that, then you'll get the square root of 0.16. And then down here in the denominator, I might as well do this multiplication right there. So 2 times 0.04 is going to be 0.08. Oh, so, and they're both, this is negative here, so that's negative there. Okay, so far I've written down the formula. Write it down every single time. It'll also help you memorize it to write it down. And then I've substituted my values here. And then I've taken the stuff in the radical and I've put that in my calculator and I came out with 0.16. Okay. Now I'll tuck this back over here. Oh my. Okay. So now I'll take my square root. The square root of 0.16 is 0.4. So I'll write that. I've got d equals negative 0.8 plus or minus 0.4 all over negative 0.08. Okay. So then the last thing that we have to do is we'll look at the two cases. One with the plus sign, one with the minus sign. And then we'll figure them out separately. And that'll give us our two different solutions. So let me tuck this over here again. And I kind of like to do them almost at the same time, just so I don't forget. This is totally optional, it can depend on the way you think, but I like to just put a line right there. And I remember on one side I'll do the plus, and on the other side I'll do the minus. So if I do the plus here, we have d equals negative 0.8 plus 0.4 over negative 0.08. And then on the other side, I'll do the version with the minus. If you put this in your calculator, all in one go, which you're welcome to, you'll have to put the whole numerator in brackets, because your calculator has no way of knowing that you mean, when you put divide, you mean like a big long division sign like this. So the only way it will know is if you put the numerator in brackets. Okay, and if you do this, you can do it in 2 steps or in 1 step, but you come out with 5. D equals 5. Okay, and then over here, on the other side of the line, I'll do the version with the negative. So d equals negative 0.8, and now I'll use the minus of the plus or minus. 0.4 over negative 0.08. And then when you put this all in your calculator, you'll have to put the numerator in brackets again. You get 15. So we have our two solutions, our d equals 5 and d equals 15. And now, so if the question is written in a sentence, then your answer should also be written in a sentence. So just to go back to the question, it says at what horizontal distance will the ball be 3 meters high? And our answers are distance, horizontal distance, because remember that's what the d is, represents the horizontal distance, and it's in meters. So the d is either 5 meters or 15 meters. So for a nice sentence here, we'll have the ball will be 3 meters high at a horizontal distance of so my first answer down here, 5 meters. And again, at 15 meters. That's my second answer. Okay. So we won't always write the sentence like that, but just where the ball, if we're looking at a sketch of what's happening here, the ball goes up, and then it comes down. And the 3 meters high line looks something like that. So here's the 5 horizontal meters, it's 3 meters high. It goes up to the top, and then it comes back down, and it's again at 3 meters there. So you can always feel free to use your calculator to get an idea of what's going on with your picture, if that helps you sort of understand things. Okay, so that's how we solve when it's going to be 3 meters. Now I'm going to do 2 more examples, which will be pretty similar, but just slightly different in the way that the equations come out. Okay, so this one looks almost the same. Casey throws a ball in the air again. H still represents the ball's height in meters, and D represents the horizontal distance it travels, again in meters. And its path can be represented by the same equation, negative 0.04 d squared plus 0.8 d. Now I want to know what horizontal distance the ball will be 4 meters high. So this feels almost exactly the same. So we're going to substitute, this is the horizontal distance. Oh, sorry, the height. The height is 4 meters. So we'll substitute for h. So we have 4, and I've replaced my h with 4, equals 0.04 d squared plus 0.8 d. And then again, like I did before, I'm going to subtract 4 from either side. Just going to make myself a little more room here. So I'll subtract 4 here, and I'll subtract 4 there. So now we have 0 equals negative 0.04 d squared plus 0.8 d minus 4. So now I've got my quadratic equation arranged just how I want. It's got equal to 0. And I've got the d squared term first, and then the d term second, and then the constant term last. So we're just taking a minute and write down my a and b and c values. A is the coefficient of d squared, so it's negative 0.04. B is 0.8. And C is negative 4. Okay, let me tuck those away over here. Okay. So now I'm going to substitute into the equation. So I always write down the equation first. And the equation starts off with x equals, or in this case, d, because our independent variable is d. So d equals negative b, and remember this, writing this down every time will help you memorize it. B squared, plus or minus b squared minus, b squared minus 4ac. C all over 2a. So now d equals, now I'll substitute, be careful with your negative signs here. We've got negative, and this is a positive number, so it'll be negative because it's negative b. Plus or minus b squared is 0.8 squared minus 4 times a, which is negative 0.04, times c, which is negative 4. And all of that over 2 times negative 0.04. Okay. So again, I'll suggest that the first thing you do is to take the stuff in under the square root sign and pop that all in your calculator. And something interesting happens in this case when we do that, because we get 0. And we'll look at why that's interesting. And then in the denominator we have 2 times negative 0.04, which again is negative 0.08. So here's the reason that's interesting here is because when we look at the 2 cases of the plus and the minus, they're going to be exactly the same, because square root of 0 is 0. So the 2 cases here, the first case will be d equals negative 0.8 plus 0 over negative 0.08. And the second case is going to be d equals negative 0.8 minus 0 over negative 0.08. So adding and subtracting 0 both do nothing. So in this case we've got, that comes out to 10, and this guy also comes out to 10. So, interesting terminology here. This is called a double root. So that means that there's one, the vocabulary we had been using, we've been calling this either two equal roots or two equal solutions, or it's one solution. And this is why we call it two, because it comes out to sort of two different ways from two different calculations, but you get the same solution both times. So we get a double root. It happens when. So when does it happen? Well, it happens when the plus or minus in the equation gives us plus or minus 0. So that means it happens when this stuff in the square root sign is 0. So the stuff in the square root sign is b squared minus 4ac. So we have a double root, or two equal solutions, and that happens when b squared minus 4ac equals 0. There's a special name for b squared minus 4ac. It's called the discriminant. And you'll be expected to know that later, but you don't need to know that right yet. Okay, let me tuck some of these things away over here. We'll just finish up the answer, because again, the question here was in a sentence, so the answer should also be in a sentence. If we look at back where our answer was, we had right here, remember the question was at what horizontal distance will it be 4 meters high? And the answer is 10 meters. So the ball will be 4 meters high at a horizontal distance of 10 meters. Okay, and in terms of the graph this time, what it would look like, we have our ball doing more or less that. And if there's only one place that's 10 meters high, that means that has to be the vertex. That has to be as high as it gets. So that means this ball only goes 4 meters high, because there's no other place where it would hit exactly once. Okay, I'm going to just look at one more example. And you might be able to sort of imagine what happens. We're going to look at what happened if we tried to figure out when the ball was 5 meters high. So, same question. At what horizontal distance will the ball be 5 meters high? And we're pretty sure, because it's the same equation as last time, we're pretty sure this ball doesn't get 5 meters high, because we're pretty sure the vertex is 4 meters high. So, let's look at what happens. We've got 5 equals negative 0.04 d squared plus 0.8 d. And then to isolate, to make it equal 0, we'll subtract 5 from both sides. So I'll just quickly identify my A and B and C. A, again, is negative 0.04. B is 0.8. And C is negative 5. Okay. So I always write out my equation. D, let's do that in red. My D value, so it's the negative B plus or minus the square root of B squared minus 4AC all over 2A. So D is negative B plus or minus, oops, now I'm going to substitute. So my B value is 0.8, so negative 0.8 plus or minus the square root of, so B squared would be 0.8 squared minus 4 times A is negative 0.04, and C is negative 5. Okay, if you look at what I have on the screen right now, just before I go any farther, this is the place to watch out for, because right now what I have written is wrong. It's wrong because I've got to make sure the square root sign comes all the way to the end of the line here. Otherwise it means that I'm only taking the square root of the first part, which is not what I mean. So it's easy to happen, just because sometimes you don't know like how much space this part here is going to take up. But always when you get to the end here, just look up and make sure your square root sign goes all the way. Okay, that's a little detour. So we're in the middle of substituting here. The square root sign goes all the way, the fraction line goes all the way. And we're putting this over 2 times a, which is negative 0.04. Okay. Oops, sorry about that. Okay, so d equals negative 0.8. And when I put all this in my calculator, all this stuff under the equal sign, I get negative 0.16. So, what's going on here? What's interesting about this? Well, the main thing that's interesting is that the square root of negative 0.16 is not a real number. So far your teachers have probably said things like you can't take the square root of a negative number, which isn't exactly true, but the answer isn't a real number. So in terms of this case, what height is this going to be? Well, there's not going to be any height. This equation here isn't going to give us any real solutions. It doesn't, in terms of the number system that you know and use, there's no answer. Which makes sense because we sort of knew from what happened in the previous questions that the ball doesn't get this high. Okay. So as soon as let me do this one at a time here. Put this here. And put this here. So what we have right now is we have no real solutions. And the reason we have no real solutions is because we're trying to take the square root of a negative number. And the thing that makes that happen is if we have, see up here, this thing under the square root sign, that turned out to be negative. So that means there's no solutions. So it's since b squared minus 4ac is negative. Okay. So in some algebraic context where we're not actually measuring lengths and heights and stuff, I'll show you how you can simplify this. But for now, in this case, the question is when will it be 5 meters high? And the answer is it's never going to be 5 meters high. Because we can't get a solution from this. So the ball will never be 5 meters high. Alright, I hope that was helpful. I'll see you in class soon.